China just tried to land a rocket that looks almost identical to SpaceX's design. Stainless steel body, 9 methane engines, vertical landing system. Landspace's Zhuk 3 launched perfectly and reached orbit without any problems. But during the booster's return, a fire suddenly erupted mid-descent and the entire vehicle slammed into the ground in flames. Why did it fail at the exact moment SpaceX succeeds 260 times out of 300? The launch went flawless, the separation clean. So what makes the landing burn so brutally different when you're just copying the blueprint? Let me take you back to what actually happened. The Zhuk 3 stands 66 meters tall, powered by 9 Tian methane engines, generating 730 tons of thrust at liftoff. Landspace built it entirely from stainless steel, the same material SpaceX chose for Starship after years of testing showed it handles extreme heat better than aluminum or carbon fiber. This wasn't their first rodeo either. Back in 2023, Landspace's smaller Zhuk 2 became the world's first methane-oxygen rocket to successfully reach orbit and deploy payloads, actually beating SpaceX to that specific fuel combination on an orbital mission. So why would a company with that kind of achievement suddenly crash and burn trying to land a booster? The mission was already delayed once due to an undisclosed technical issue. When Zhuk 3 finally lifted off, every system performed exactly as designed. The 9 engines roared to life, the rocket climbed smoothly through the atmosphere, and stage separation happened right on schedule. The upper stage continued toward orbit and successfully inserted itself into the planned trajectory. From a pure launch perspective, this was flawless execution. China had proven their engines work, their fuel systems function, and their flight computers can guide a rocket to space. But here's the problem. Getting to orbit is only half the equation when you're building a reusable rocket. The booster began its descent back to Earth. Long-range cameras tracked it falling through the sky in what looked like a perfectly controlled trajectory. The vehicle was oriented correctly, its grid fins were deployed, and for those first crucial seconds, everything appeared stable. Engineers watching the telemetry probably felt cautiously optimistic. Then, at low altitude, something catastrophic happened in an instant. A bright flash of fire erupted from the booster's engine section. Thick black smoke poured out as the vehicle started tumbling. The descent rate accelerated far beyond what any controlled landing burn could handle. Within seconds, the booster smashed into the ground just meters away from the intended landing pad, erupting into a massive fireball that left wreckage scattered across the site. Based on the timing and altitude where the failure occurred, analysts believe the engines failed to ignite properly for the landing burn, or a fuel line ruptured the moment propellants started flowing at high pressure. Once fire breaks out during a hypersonic descent, there's no recovery. You're committed to a crash. Here's what makes this failure so revealing. The exact same thing happened to Blue Origin's New Glenn just weeks earlier. New Glenn is Jeff Bezos's answer to SpaceX's Falcon Heavy, a massive rocket that spent over a decade in development with billions of dollars poured into it. When it finally launched, the ascent was perfect. All 7 BE-4 methane engines fired beautifully, and the upper stage reached orbit and deployed its payload successfully. Blue Origin achieved their primary mission objective. But when the booster tried to land on their drone ship in the Atlantic, they lost contact during the final approach, and the entire first stage was lost at sea. Blue Origin admitted the landing conditions were tougher than expected, and their recovery system needs significant work. Sound familiar? 2 different companies, 2 different countries, billions in combined funding, both using methane fuel like SpaceX, both studying SpaceX's techniques, and both failing at the exact same moment. The landing burn. Why does this keep happening to everyone except SpaceX? Let me show you the difference. SpaceX didn't start out perfect either. Their early Falcon 9 boosters crashed repeatedly into the ocean and exploded on landing pads throughout 2014 and 2015. Each failure taught them something critical about engine restart reliability, fuel slosh dynamics, grid fin control authority, and the precise timing needed for those final seconds. But here's what separates SpaceX from everyone else. They kept flying. They didn't pause for years after each failure to redesign everything. They analyzed the data, made targeted fixes, and launched again within weeks or months. Today, SpaceX has launched Falcon 9 over 400 times total, with more than 260 successful booster landings. Some individual boosters have flown 20, 23, even 24 times. A single first stage that used to cost $60 million and get thrown away is now flying more missions than entire rocket programs used to complete in a decade. Last year alone, SpaceX completed over 130 Falcon 9 launches, more than most countries achieve in 5 years combined. They launch so frequently that a Falcon 9 landing barely makes news anymore unless something unusual happens. The technical mastery involved is brutal. After stage separation at 70 to 80 kilometers altitude while traveling several thousand kilometers per hour, the booster is completely on its own. Onboard computers use GPS, inertial sensors, and those titanium grid fins to calculate the return trajectory in real time, adjusting for wind, atmospheric density, and fuel remaining. If there's enough propellant margin, the booster performs a boost-back burn to reverse course and head directly back to the launch site, landing on concrete pads at Cape Canaveral or Vandenberg. If the mission requires maximum performance, it targets one of SpaceX's autonomous drone ships positioned hundreds of kilometers downrange. Ships with names like Just Read the Instructions and A Shortfall of Gravitas that hold position in rolling ocean swells using dynamic thrusters while the booster screams toward them at supersonic speed. 3 precisely timed burns make it all work. The boost-back burn adjusts trajectory. The re-entry burn protects the vehicle from ripping apart as it slams back into thick atmosphere at hypersonic velocity. Then comes the moment of truth. The landing burn ignites just seconds before touchdown, using 1 or 3 engines to decelerate from hundreds of kilometers per hour to nearly 0 in about 8 seconds. The landing legs deploy, and the booster settles onto the pad or ship within meters of the target point. That final burn is where Zook 3 failed. That's where New Glenn failed. And that's where SpaceX spent years perfecting every microscopic detail. So what's the real lesson here? You can copy the exterior design, the fuel choice, the engine configuration, even the stainless steel construction. But you cannot copy the thousands of hours of flight data, the failure analysis, the software refinement, the supplier relationships, the institutional knowledge of what works and what kills crews. Landspace built a rocket that looks like SpaceX's work. Blue Origin hired former SpaceX engineers and studied every public detail of Falcon 9 landings. Neither could replicate the result when it mattered most, because rocket science isn't about blueprints. It's about the brutal, expensive process of failing, learning, and iterating faster than your competitors can even build their first prototype. Here's what this failure really tells us. China's space program has achieved incredible things. They've built a space station, landed rovers on Mars and the Moon, and Landspace actually beat SpaceX to orbit with a methane-oxygen rocket. They have the talent, the funding, and the determination. But this crash exposes a hard truth that no amount of money or engineering skill can shortcut. Mastering reusable rockets isn't about copying the design. It's about surviving the learning curve that comes from repeated failures. SpaceX exploded rockets for years before they figured it out. Blue Origin just lost their booster on their first attempt. Landspace joins that list now. The companies that will succeed in reusable launch aren't the ones with the best blueprints. They're the ones willing to crash, analyze, fix, and fly again before their competitors even finish their investigation reports. SpaceX launches every few days. That pace of iteration is their real competitive advantage, not the stainless steel or the methane engines. You can study their rockets all you want, but you cannot buy the institutional knowledge that comes from 260 successful landings and counting. So, will Landspace figure it out? Will Blue Origin nail their next landing? The answer depends entirely on how fast they can iterate and how many failures they're willing to endure before success. What do you think? Can anyone actually catch up to SpaceX's landing mastery, or is the gap too wide now? Drop your thoughts in the comments below. If this breakdown gave you a new perspective on why rocket reusability is so brutally difficult, hit that like button and subscribe to New Space Review for more deep dives into what's really happening in the space industry. We cut through the hype and show you what the data actually reveals.